So I am Paul Stanton, I'm the product manager for Pulsar, and at these type of events everyone goes, what's Pulsar? And Pulsar is our design system which we use to build our user interfaces within our software. At kind of a granular level, it controls little things like how the buttons are built and styled and consistent throughout the software, all the way up to more complex components like how a full user interface like new form builder, or the rules you might have seen both CXM and XMP all kind of fit together. The Pulsar there's a team that manage it, and aside from working in the products and doing interface design, we do some research and development as well, and start to explore new things, which is a good thing to show off at the end of the day. So two things I'm going to speak about today. The first is a piece of work we'll be kicking off. Well, it's already kind of started to kick off this year, but properly getting into gear at the start of next year, which is our Companion App. Now, we already have an app, and you might know, you might not know, but our first app that's in both the iOS App Store and the Google Play Store is our two-factor authentication app. It's a setting within your Continuum platform that you can enable extra security for logging in, and you might be familiar with it if you use banking or certain interactive government systems. You generate a 16-digit code, and you put in your username and password, and then you have to supply this as well. And this was our first foray into building native mobile web apps. And our next offering will be a bit more ambitious in scope. It's the Companion App for Continuum CXM. What we wanted to do, and CXM at the moment you can already use on a mobile device, whether that's a phone or a tablet, using the normal responsive web use. But what the app will let us do is to squeeze Continuum CXM into a native mobile app and streamline that experience. So some of the tasks you might not want the full desktop experience and the responsive web use, you might want something a bit more targeted. And we've been doing a lot of back-end engineering to get ready to start building this out. So a lot of the stuff you'll see here are just mock-ups. The first things we've had to do is kind of redesign how customers log in to CXM and generally the Continuum platform. At the moment, each organisation has its own login screen, but we only want one app in the App Store. We don't want everyone to have their own app, because that's just no one wants to do that. So we needed to start thinking of organisations and a way for you, if you've used Slack or any kind of other SaaS service, you specify what organisation you belong to and then you can sign in. So some of the screens I'll show you, let's pretend we are an agent working in the field, say, sorry to bring up again, like missed bins. And again, it's a mock-up, you can imagine reference numbers will be different, but this might be a third-party contractor who you've granted access to the app and to view certain information on the go. So they can see their assigned cases and which ones are in progress and which ones are closed. And they can go in and see that lovely timeline view, all that conversation with between the customer, the member of the public and the council and whoever else is involved. They can script through that, see that information and contribute. They can send a message and say, I'm on my way, I'm a bit late, kind of increasing that real-time communication because they've got this in their pocket. They can access all the native functionality on the device, like mapping. We can use local storage, and another part of that engineering that's going on at the moment is figuring out how we can encrypt that local storage. We've heard a lot about GDPR and stuff today, I won't bring that up again, but making sure that we're ready to start building the app out. Reporting and MI information right in the app, if you have access to it. Everybody loves charts, and we can help you see how far along that journey are you of reducing your phone call inputs. And the same reporting will be available on your desktop, and it just look nice on the phone. We're talking about missed bins, so this has been tailored to show the collection days, the bin types, the channel if you wanted. Different case types might show the information in a slightly different way. This is bulky waste collection. See at the very top, like Tom demoed earlier with the person notes, we can show them right in the app, so your people who are actually going door to door can get that critical information if they need it, hopefully stay safe. The collection days, time slots, things, items to collect, all customised based on the case types that you're going to create, to be honest. And we can progress it through the workflow right from the app. So we don't have to wait till we get to the back office and start running through our cases. We can do it, tap straight away. If this case isn't for me, I can assign it to someone else, or I can mark it's collected or unable to collect and add notes and straight away. Nice and streamlined, makes sense for a mobile context, and we're going to start breaking ground on this next year. Now the next big thing is machine learning, and this is where I start to wave my hands a bit, gesticulate, try and fill the gaps, because this is something very new that not just we're experimenting with, but the industry as a whole. And machine learning is a way for us to almost give you, sounds fluffy, but almost give you a superpower. The kind of combination of an expert human and a machine that can help with extra information is quite powerful. The first area we've been exploring, so I was kind of with the earlier, is sentiment analysis, not sentient, we're not quite there yet. But the ability, given a block of text, and that might be a timeline message in CXM, or it might be a form submission through your Contact Us form, given that text, we're able to push that into a machine that's been trained to give us an estimation on whether that's written in a positive tone of voice, or a negative sentiment, or probably somewhere in the middle. And then the step now is figuring out how to use that information. So this is a mock-up of how it could be presented within CXM. You see Michael here, start this case, my bit wasn't collected this morning, we can absolutely bring it to him. We can tell, I mean, you know this, and I know this, he's not happy. But the machine knows this as well. And maybe viewing on a specific message isn't massively useful, we can do that ourselves, but what the machine can do for us that we can't do is monitor every message across all the case types in near real time and start to process that information in aggregate and start to highlight some areas where maybe we should be looking at this case first. And we can see across the history as we've interacted with this customer that hopefully by the end we've made them happy. And maybe that won't make sense across all case types, but for some, especially your frontline services, that could be useful measuring information. And then we start to expand upon that, and what I want to kind of you to take away from this bit is to, given you now know that this possibility exists, where could you start to apply it? Could it be that, given a single person, you track the conversation history and try and find out at what point the tables turned, either made them happier or unhappier, and use that for training? It's kind of the future of this call is training, recorded for training and monitoring purposes. Could you monitor all the conversations across a case type and kind of get a happiness meter? How well is this service performing, or over time, as we brought this service online, has it improved, has it declined? If you're in a business-to-business context, do your account managers want to know how that relationship's going? And part of the story is we need a way of correcting it, of course. Sometimes the machine's not perfect. And in all honesty, we're all friends here. We can download models that help us get the machine trained, and that involves getting a lot of sample data, and pretty much telling the machine to train itself. But we found that the models that come out of big research universities in the US are very Americanized. So we almost need to train it with our own data. But we wanted to get a jump start on that training. So we built our own bot, which I'll show you in a minute. And you've been training machines for a while now. You've probably filled in a lot of these in your past. Recapture, this is the old version, not version 2, so I'll show. But this was a way of getting humans to recognise text and to help with the digitisation of books. The machine will give you 2 words, one of which it already knew. The other one it wanted you to confirm. And the bet is that if you got the control word right, then the challenge word you're probably going to get right as well. And it asks the same question to multiple people, and if enough people give the same answer, job done. Seen these ones recently? Nuts? We're helping to train the algorithms for self-driving cars and for machine vision. So we're telling cars this is what street sign looks. Hopefully not in real time. I'm hoping there's not a car waiting for you to confirm which way it should turn. But all this data, and luckily Google can do this at scale, and they can send this out to thousands of people and help to train that. And then those models, like for image recognition or text recognition, are all open source, and we can download them and expand upon them. So this is our little training bot, and we call it Miyagi. And Miyagi takes real text from the Jadu support system, which of course runs on CXM, and asks Jadu employees who have access to this data to rate it, whether they think it's positive, neutral or negative, or sometimes we can't really tell. And we feed that back into the model to help it get better. And we feed that back into the model to hopefully get it better at recognising sentiment within the context of CXM, so we can figure out between all these links and technical data what the sentiment's going to be. So this, you could probably expect to see this within CXM soon. Probably absolutely not visible to members of the public. We don't want them knowing that the angle of the sound, potentially the quicker we'll see their case. But it's an interesting experiment to try and see where we can take a technology like sentiment analysis. And the next step is vision. So we've only been, the scope of machine learning is huge, and there's all sorts of things we can do. We're focusing on sentiment and vision at the moment. And vision is the ability to make the machine recognise things within an image. So, this is your common garden Jadu interface powered by Pulsar. Okay? We have an old image upload, such as you would see in Continuum CMS. And if I find my mouse, which is over here, I'm going to grab an image. Let's pick this fancy one, and I'm going to drop it. And what we're going to see is, in a second, Wi-Fi permitting. It's generated a description of a mouth-like garbage and C tags, so it's categorised it with everything it thinks is in this image. And now straight away, this bit is absolute gold for accessibility and for screen readers, because with the best will of the world, your content authors don't always do the best job at providing descriptions unless you've got the thumb screws on them and great style guides, and you kind of force that process on them. And automatically generating the tags helps phenomenally with search. But in the future, if I want to go into my system and look for an image of the beach, the machine's already tagged all the images that have been uploaded, so I can search and see which images already exist and pick the right one for the job. And of course, these are all correctable. I can go in and add new tags. I don't want it to be categorised as sandy, and I can go and modify the description, because it's not always perfect. But it's a good first step, and it's a good suggestion. And part of the whole reason for doing this is one of our, as an organisation, is to reduce the friction of tasks as much as possible. To make the day-to-day jobs that you do as simple as possible and kind of help as much as we can. That's a picture of my apple tree in my garden. What's it going to come up with? Oh, no, this is obviously not what I know it's going to come up with. An apple tree hanging from a branch. And that, to me, I mean, I know I'm biased, but that's magical. Kind of, I still don't completely understand how you can look at it and say, right, it's been showing enough pictures of an apple that it knows what an apple is. And it's been showing enough pictures of a tree and told this is a tree that it knows what the tree is. It's never seen this image before. But then it can build the context of it and say, right, it's an apple hanging off a tree, or a person flying a kite on a beach. It's not just saying kite. Anybody know? Well done, Admiral Grasshopper. Now, machines have seen this image enough times and been told who this person is enough times that our description is Grasshopper wearing a suit and tie. Now, it's categorised it as man, which, yeah, that's not entirely true, but that's why we put in the correction and feed that training data in. So by removing that tag, we can feed that action back in and help to constantly improve the model. Imagine within CXM and users uploaded an image that you get notified about. Now we're able to tell you in that notification the person has uploaded an image of this, and maybe rating that. And then we can do all sorts of amazing things with images. Not all necessarily machine learning driven, but certainly helped along. So we can do face detection. Other algorithms can do it, but machine learning, because that's constantly improving, it's building on the shoulders of the giant research universities, your Googles and your Apples, that are all helping to improve the models. We can take those and straight away recognise faces. And if you can recognise the subject of a photo, it might not just be a face, it might be a building or a car or a dog is really good at animals, these models, because that's what they're trained with. You can then provide smarter crops. So if we're doing responsive web design, we're building the tools within like galaxies to shrink your site to a mobile phone, we're able to automatically know what the subject is of an image. We can help you along by creating those small versions, keeping the subject in the centre frame. Then we can pull out colour palettes from an image and use that. Maybe we use that to help design a theme. And we can detect emotion again, but from faces this time. Which this was cool to demo, and I struggled for a while thinking, well, how's that useful? But if I want to search my image archives for happy people or sad people, that's where that comes in. So that ability to recognise things within an image and categorise images quite well helps in different ways. So we're back on waste. But imagine I've got a fridge that I want to have collected, and this is an example, bulky upload form from an actual customer, and as forms go, it's pretty good. It's well organised. We have this list of categories that you drill through, but personally, I made a mistake, and I categorised my fridge as electrical equipment, and it's not his kitchen. And yeah, that's a split-second mistake on my part, but it's a tiny bit of friction that, by using image recognition, maybe we can help that along. What if I could start my book with a picture and take a picture of the actual thing I want to send in? The machine knows it's a fridge. It can tell with quite a different confidence score. And maybe we can train it to recognise a mini fridge from American-style fridge freezer. So within your services, you can then probably make a decision whether you need a one-person crew or a two-person crew with a tail lift. And the more decisions or the more guesses we can make, the fewer questions we actually have to ask if we're able to ask the right questions. Could you imagine a more conversational interface rather than your traditional web form? Could you book a collection through a text message? I just text my thing to the council. They can recognise it, and they know where I live. Not as creepy as it sounds, my address is on my account. So we don't need them to enter that address again. We can just get the check. Is it from you? Yeah, we can sort that out. And we're into the weeds of theory now, and I appreciate that. And there's a lot of decisions to be made about how we do this, but it's about showing what's possible with the technology and where we could go with it. So let's get off waste for a while, probably for the rest of the day. I want to report a problem. Now, this frustrates me because the current model for most places is, right, find the right form and fill it in. So if I just want to tell you about the car at the end of the street that's got a flat tyre and its window stoved in and it's been there for 3 months. Right, where's that form? I've either got to be comfortable enough using the search and know that I want to search for like abandoned cars or dumped cars and trust that the website's organised well enough, or I've got to start that journey through the navigation and trying to find that full, right, is it highways, is it roads, is it... And then, when I find the form, if I've stuck it out through that journey, then I can report my problem, if I'm still bothered. So the burden there is squarely on me, or on the users of this. So how can we reduce that friction? I just want to report a problem. And you should ask me, right, what is the problem? And then, through clever form design, clever directions and stuff, then I tell you what the problem is, you figure it out. You get it to where it needs to go. Don't make me find out which form I need to fill in. Figure it out. And then again, machine learning can help with that. If I start with an image, if I'm uploading an image of a car, there's a good chance I don't want to talk about street lighting, unless there's a lamppost in the image. Graffiti, smashable shelters. But I want to report a problem. Take a picture of my street light, upload it, show you where it is. And mobile phones capture the location information right in the image. So can you pull that out? Well, this isn't machine learning, this is just service design and using technology to our advantage. We can get the location from the image and get them to just confirm, is this right? Is this where it is? And if we want to be smart, we could say, right, is there a reference number on the lamppost? If it's in the image, we can use text recognition to grab it off. And text recognition's fascinating. It's been around for decades. But then if you're in this mindset of how we make the machine help us, and someone uploads an image of a PCN, and they're doing a parking fine appeal, and the machine's been trained with enough images of PCNs, so it knows, right, this is a PCN. Then it can run text recognition on the top. We can get numbers, we can get dates and makes. This isn't my phone, by the way, I don't have a Jaguar. Contravention codes, civil enforcement officer numbers. How far along a case type could you get the person from this image? You know where they live, you know all this information, just by starting from a different viewpoint, by starting by saying, right, send us your PCN. The machine can do all this level for us. The biggest challenge is figuring out how we're going to use it. And that combination of humans and machines is our direction of travel for the next few years, really. And implant those ideas, those possibilities into the back of your brains. And when the journey's home, think about how we could use it in the future to improve how we serve the people that we serve. It's fascinating to kind of figure out what we can do. So thank you.